NASA has released more photos from the world's most powerful telescope, revealing the deep secrets of...
Astronomers and scientists keeping a very close eye on a strange traveler that began its journey to our solar system.
A quiet wave of panic hit the planetary science world the second mission controllers spoke up. The James Webb Space Telescope had picked up something seriously off about the path of an object now known as 3I Atlas, and from that moment, nothing felt normal anymore. At first, it was brushed off as just another cosmic drifter, similar to earlier interstellar visitors that slid through the solar system and vanished without a trace. Just another blink-and-you-miss-it space guest, or so everyone thought. But Webb's data was screaming a different story. Unlike those past objects that flew in and out clean, 3I Atlas wasn't playing by the usual rules. Instead of sticking to a smooth, hyperbolic exit, it started acting weird, drifting off course in a way that didn't sit right. Analysts spotted it first, a tiny but steady shift in speed and direction that ground telescopes couldn't catch, but Webb absolutely could. That one strange detail turned a boring data point into the biggest space mystery scientists have faced in years. As researchers dug deeper, alarms really started going off. Teams across NASA reran the math again and again, using different models, hoping it was just bad data. The object was new, its brightness was unstable, and early readings were messy, so doubt was still in the air. But Webb doesn't lie like outdated tech does, and every recalculation pointed to the same wild conclusion. Then came the shocker. The refined trajectory showed 3I Atlas sliding onto a path that would bring it dangerously close to Mars. Not a flyby, not a near miss, but a straight-up impact course if the numbers held. This thing wasn't just passing through the block, it was charging right in. That truth spread fast, jumping from a few orbital number crunchers to entire squads of astrophysicists, geophysicists, exobiologists, and mission planners. Non-stop emergency calls took over as the implications sank in and the vibe flipped from curiosity to full-blown crisis mode. Before we go further, smash that like button and subscribe for updates, because this story is only getting crazier. An interstellar object slamming into a rocky planet was something scientists only talked about in theory, never something they expected to actually see go down. The solar system has taken brutal hits before, sure, but those impacts were leftovers from its own messy birth, not outsiders crashing the party from another star system. This situation hit different, and everybody in the field knew it. The idea that a rogue traveler from deep space was now locked in on Mars flipped planetary risk models upside down. This wasn't just another space rock drifting through. This was a whole new type of threat scientists weren't fully ready for yet. And at the center of it all was 3I Atlas itself, an object already breaking expectations left and right. Webb's infrared scans showed something wild. The surface looked packed with complex carbon-based compounds, but mixed in were metallic patches shining back light in a way that felt off, almost too clean. This wasn't behaving like Borisov with its dusty coma, and it definitely wasn't like Oumuamua with that flat shape and chaotic spin. 3I Atlas was playing by its own rules. Even stranger, heat wasn't spreading evenly across its surface. Some areas held warmth like a furnace, while others stayed cold, hinting at either a dense rocky core, layered insulation, or something scientists couldn't neatly label yet. The debates got heated fast, because none of the usual models lined up perfectly. Then came the pulsing brightness. Its reflectivity rose and dipped with every rotation, almost like it was breathing under the sun's glare. The way sunlight reacted with its surface geometry made zero sense with basic explanations. NASA finally spoke up after review kept landing on the same result. This wasn't a math slip-up, and it wasn't bad data. Webb's numbers were rock solid, and ignoring them was no longer an option. When the announcement dropped, attention exploded worldwide. Scientists stressed that Mars, uninhabited and rugged, would take the hit, not Earth. Still, the bigger picture loomed large because a collision like this would offer a once-in-a-lifetime chance to study alien material smashing into a terrestrial world, and the scientific payoff could rewrite everything we think we know. The focus quickly flipped to one burning question: where did this thing even come from? Interstellar objects don't just drift randomly. Their speed and angle carry the fingerprints of the star systems that launched them. By breaking down those numbers, astrophysicists traced 3I Atlas backward across the galactic plane, and the results were wild. The models showed it roaming deep space for millions, maybe even hundreds of millions of years, before the sun finally grabbed it. Its makeup backed that up too. The materials hinted at a birthplace around a star older than our own, packed with heavier elements the sun never had access to. That meant 3I Atlas wasn't just ancient. It was carrying minerals shaped long before the solar system even existed. If it slammed into Mars, that alien matter wouldn't just vanish. It could scatter across the surface, mixing into the red dust and locking pieces of its origin into the Martian soil for future missions to dig up and study. That alone had scientists buzzing. But the real stress point never went away. The orbital anomaly kept refusing to make sense. Normally, interstellar objects follow clean gravitational paths once they enter the sun's influence. 3I Atlas didn't. For it to veer this hard, something had to be pushing it, or it had to be pushing itself. Some researchers floated the idea of jets from sublimating material nudging it off course. But Webb's data didn't show the energy patterns that kind of outgassing would create. Others pointed at possible past encounters with unseen small bodies, maybe early in its journey. Still, nothing explained why the deviation got stronger the closer it came to the inner solar system. That part rattled everyone. Once NASA released the data, public labs worldwide jumped in, running non-stop simulations. Different methods, different assumptions, same conclusion every time. All credible models locked onto one terrifying detail. The projected intersection with Mars sat inside a razor-thin corridor only a few thousand kilometers wide. On a cosmic scale, that's basically a bullseye. The collision wasn't immediate, but the timeline left plenty of room for intense observation before everything goes down. This moment flipped from a distant threat into a live, high-stakes science event that humanity could actually watch unfold. For the first time ever, researchers weren't guessing after the fact. They had front-row seats with modern instruments locked in and ready. Attention quickly shifted to what Mars itself would face when 3I Atlas finally made contact. Current estimates put the object at several hundred meters wide, and those uneven heat readings hinted it could be even bigger if it's packed with dense material. Either way, the math was brutal. The energy released on impact would rival thousands of megatons of TNT, an absolute monster of a collision. Mars wouldn't stand much of a chance slowing it down. With its thin atmosphere, the object would smash into the surface at near full cosmic speed. The crater left behind would tower over most recent impact sites in the solar system, sending shockwaves racing through the crust and possibly waking up long silent geological regions. The aftermath would be just as wild. Massive plumes of dust and debris would blast into the fragile Martian atmosphere, briefly reshaping temperature patterns across the planet. For scientists, that chaos meant opportunity. Planetary geologists were locked in on one major prize. The impact could tear open deep underground layers that normally stay sealed without extreme drilling. Materials hidden for billions of years could suddenly be sitting right on the surface. Astrobiologists saw something even bigger. Ancient pockets of water ice, salts, or chemical reservoirs tied to past microbial life could be exposed in a flash. The impact would crack those layers open, offering a short window to study them before Martian winds scattered everything. For experts who've spent decades pushing for robots to dig deeper, this destructive arrival was a dramatic, no-permission-needed alternative. and spectroscopists were just as hyped. Once fragments of 3I Atlas spread across Mars, science would gain the cleanest samples of another star system ever found. Unlike meteorites that drifted around our system forever, these pieces would carry untouched chemistry straight from a distant star's birth zone. Webb had already hinted at complex organic molecules on its surface, raising the jaw-dropping idea that life-building chemistry might be everywhere in the galaxy. A direct hit on Mars would blast those strange compounds across a planet already under non-stop astrobiology watch. Mars is crawling with active robotic missions, and those machines instantly became part of the conversation. Rovers and landers scattered across the surface could actually feel the impact, picking up seismic waves unlike anything recorded before. Seismometers would track vibrations ripping through the crust, mantle, and even the core, giving scientists the clearest look yet at Mars's inner makeup. Up above, orbiters would be working overtime. They'd capture the dust plume as it exploded outward, track atmospheric shock waves, and map heat signatures spreading across the planet in real time. All of it together would form a full live snapshot of a planetary collision from start to finish. That kind of data is basically unheard of, and researchers knew it. At the same time, mission planners started thinking bold, real bold. The idea of a rapid response probe came up fast. A last-minute interceptor could race out toward 3I Atlas before impact, snapping ultra-detailed images and grabbing spectral data no Earth telescope or even Webb could fully capture. Even a quick flyby would be a goldmine. Scientists could finally lock down its rotation speed, mass balance, and surface structure. That info wouldn't just explain this object, it could shape how humanity handles future interstellar visitors. And let's be real, that matters. If something like this ever lined up with Earth, this knowledge could be the difference between panic and preparation. Beyond the tech and the data, this discovery hit deeper. For centuries, people treated the solar system like a closed neighborhood, mostly shaped by its own planets and debris. This event shattered that idea. A foreign object on a collision path proved the system is wide open to the galaxy. Visitors from distant stars can wander in anytime, carrying chemical fingerprints from places we've never seen. What once felt calm and isolated now looked connected and unpredictable. And as Webb's data kept pouring in, one detail stood out even more. The strange heat patterns on 3I Atlas were getting stronger as it neared the Sun. That hinted at volatile compounds reacting in unfamiliar ways, acting nothing like typical comet behavior and keeping scientists on edge. Instead of blasting out visible jets or growing a classic dusty coma, 3I Atlas kept acting strange. The material on its surface seemed to absorb heat, then release it through complex internal transitions, almost like it was cycling energy inside itself. That behavior threw standard labels out the window. This thing didn't fit cleanly as a comet or an asteroid, and that alone had scientists shook. New theories started popping up fast. Some researchers suggested 3I Atlas might belong to an entirely unknown class of interstellar debris, formed under conditions nothing like what shaped objects in our solar system. One leading idea pointed to a chaotic young star system, where newborn planets fought for dominance and violently flung smaller bodies into deep space. If 3I Atlas came from that kind of war zone, its structure could carry scars from brutal collisions or rapid heating events. That would explain its odd reflectivity and those flickering surface patterns that refuse to behave normally. Trajectory backtracking added fuel to that theory too. The object's path traced back to a region of the Milky Way packed with older, evolved stars, making a strong case that this traveler is seriously ancient. Studying it, even indirectly through the aftermath of impact, could unlock clues about how planetary systems across the galaxy change over billions of years. That realization lit a fire under the scientific world. Public interest exploded as NASA slowly released more details. The agency stayed calm, framing the collision not as danger, but as a once-ever research moment. They stressed how rare it is for humanity to witness an interstellar collision during an era with tools this advanced. People started imagining Mars afterward, a massive new crater, sparkling with minerals forged around another star. Educators jumped in too, using the moment to hook students on orbital mechanics, planetary geology, and deep space exploration. But beneath the hype, tension still lingered. The models lined up tight, yet they allowed a slim margin for change. A few outlier projections hinted the trajectory could shift in the final months, either slamming deeper into Mars or barely skimming past it. Even that near-miss scenario had scientists locked in. A close pass could twist the object's orbit, maybe trapping it briefly or flinging it back out on a wild new path. Still, as the data stacked up, the main storyline stayed firm. All signs pointed toward a direct encounter as this cosmic drama kept building. Comparisons to ancient planetary smash-ups were impossible to avoid. Mars is already covered in massive scars from brutal impacts, including the enormous Hellas Basin and the mysterious northern lowlands that many scientists believe were carved out by colossal collisions early in the planet's life. Those hits came during the chaotic birth era of the solar system, when everything was crashing into everything. But this situation hit different. 3I Atlas wasn't leftover rubble from Mars's own neighborhood. This was a true outsider, a messenger from far beyond the sun, carrying geological and chemical memories from completely different worlds. Slamming into a planet already suspected of once hosting life, that fact alone changed the whole narrative. Suddenly, planetary evolution wasn't just about local history anymore. It became a story about cosmic exchange across star systems. NASA's long silence started to make a lot more sense once the math behind the orbit went public. Agencies don't rush statements when the variables are stacked this high. One wrong call could blow credibility, and this data was pushing the limits of what modern astronomy can even measure. The James Webb Space Telescope was operating right at the edge of possibility, delivering detail no one had ever worked with before. The real challenge wasn't collecting data, it was making sense of something completely unfamiliar. As uncertainty slowly tightened and agreement formed, NASA's eventual announcement reflected restraint and responsibility. Once the news dropped, the scientific world lit up. Emergency workshops popped up, mission proposals started flying, and cross-discipline teams formed overnight. Everyone wanted in on understanding every angle of this event. The potential payoff was massive. If the impact dug up deep Martian layers untouched for millions of years, it could unlock clues about the planet's lost magnetic field, vanished oceans, and ancient climate cycles. That alone could rewrite what we think we know about Mars. As the shock faded, the conversation shifted deeper. Scientists began talking about what this moment means for planetary systems drifting through the galaxy. Every star system moves through a changing cosmic neighborhood, and over millions of years, their debris paths cross in wild and unpredictable ways. 3I Atlas closing in on Mars forced a hard truth into the spotlight. Our solar system isn't isolated at all. It's part of a constantly shifting galactic web, where objects from distant suns can suddenly become part of our story. Astrophysicists have long believed that planets across the galaxy carry scars from countless interstellar encounters, most of them happening long before anyone was around to see it. Now, for the very first time, humanity was lining up to watch one of those moments unfold live. This forced scientists to rethink some old assumptions fast. Mars had always been seen as a world shaped mostly by internal forces, sunlight, and the occasional asteroid from its own backyard. But the idea that material born around a completely different star was about to sink into Martian soil added a whole new twist. It suggested that planetary evolution isn't just local business. Matter drifting quietly across interstellar space could play a role too. Even if events like this are rare, stack them up over billions of years, and the impact could be huge. A planet's mineral makeup could slowly shift, or it could pick up exotic chemical compounds it never formed on its own. As more data rolled in, researchers built detailed impact simulations. These models showed one thing loud and clear: the angle of approach would decide everything. If 3I Atlas came in shallow, it might skid across the surface before breaking apart, carving out a long trench instead of a clean crater. That kind of strike would rip open wide areas of underground layers, giving orbiters a chance to scan materials usually buried under dunes, rock bands, and sediment. On the flip side, a steep impact would slam all that energy into one spot, vaporizing much of the object instantly. That scenario would launch a towering plume of molten material high above Mars's thin atmosphere, spreading debris far and wide. Scientists argued over which outcome was more likely, running numbers on ejecta spread and how far fragments might travel. Dust behavior became a hot topic too. Even with Mars' weak atmosphere, fine particles can hang around for a long time. Past global dust storms have already shown how easily the planet can get blanketed. That meant whatever 3I Atlas kicked up could linger, drift, and reshape conditions long after the initial impact, turning this event into a drawn-out planetary transformation. If the impact kicked enough dust into the Martian sky, the effects wouldn't stop at the crater. A thick cloud of debris could temporarily change the planet's albedo, shifting how much sunlight Mars absorbs. Even small temperature swings could throw atmospheric circulation off balance, possibly sparking localized storm systems. Instruments already orbiting Mars would catch every second of it in insane detail. For climatologists, this was a gold mine. They'd get to watch atmospheric changes unfold in real time, not from seasons or solar cycles, but from an extraterrestrial collision smashing the system off rhythm. That kind of data almost never exists. Meanwhile, geochemists were locked in on 3I Atlas itself, even before impact. Every scan mattered. If its surface held minerals never seen in the solar system, it would point to chemical environments totally different from our own stellar backyard. That could mean wild isotopic ratios, rare crystal formations, or compounds forged under pressures and temperatures unknown to solar system planets. If fragments survived the impact intact, the implications would be massive. Future missions could one day scoop up pieces of another star system straight from the Martian surface. That alone could flip planetary science on its head. One of the most intense debates centered on hydrothermal activity. When a large object slams into solid rock, the pressure and heat can rip open underground ice and water reserves. Vapor, fluids, and minerals could suddenly interact in violent, fast-moving systems, just like ancient impact zones on Earth. Those sites on Earth are believed to have helped shape early ecosystems. Mars may be cold and dry now, but a fresh interstellar impact could briefly create hotspots where liquid water mixes with mineral-rich material. Even if life doesn't appear, the chemistry alone could mirror conditions known to drive molecular complexity. For astrobiologists, this wasn't hype, it was opportunity. A natural chemical lab switching on without warning. The idea had researchers revisiting old Mars mission data with fresh eyes. Some began wondering if faint traces from past, unidentified impactors were already hiding in the record. Maybe Mars had been struck by interstellar visitors before, and nobody realized it at the time. Now, with 3I Atlas closing in, those old mysteries suddenly felt a lot more real. Before this, nobody was even looking for signs like that, because the idea felt too far-fetched to take seriously. But now, ancient Martian craters with weird mineral blends or off-balance isotopic signatures suddenly looked suspicious. Those inconsistencies could be the fingerprints of objects born around entirely different stars. 3I Atlas flipped the script, pushing scientists to re-examine Mars with fresh eyes and bold new ideas. teams began blending planetary geology with galactic motion in ways never done before. What once seemed unrelated fields were now colliding just like the object itself. Mars wasn't just a local science project anymore, it was part of a bigger galactic story. At the same time, engineers jumped into action. They started mapping the best angles to witness the impact from orbit. Sure, existing Mars satellites would catch it naturally, but fine-tuning their paths could mean the difference between cool visuals and historic data. Every move had to be calculated carefully, because fuel on these long-running spacecraft is precious. NASA and its international partners went back and forth on which satellites to reposition and how far to push them. The mission wasn't about flashy footage alone. They wanted heat maps, debris tracking, plume chemistry, and seismic data that could answer questions scientists have debated for decades. Then came a bold idea. Some researchers suggested deploying tiny microprobes from orbit just days or even hours before impact. These compact devices could drop near the predicted zone, capturing the chaos from multiple angles. It was risky and aggressive, but the science payoff could be insane. Even if only a handful survived landing, the ground-level data would be priceless. Shockwave behavior, ejecta movement, surface response, all of it could sharpen models not just for Mars, but for rocky planets across the galaxy. Beyond the science, everyone felt the weight of the moment. Humans have watched impacts before, comets, asteroids, meteoroids, but never something that traveled here from another stellar birthplace. That detail gave the event a deeper meaning. It felt like Mars, a planet that's fascinated humanity forever, was about to receive a message delivered across the galaxy, written in minerals, speed, and force. That idea sparked creativity everywhere. Artists, writers, and educators leaned in, translating the science into stories and lessons of their own. And as astronomers kept refining the data, one detail stayed locked in. The object's shifting brightness pointed to a complex, uneven surface, one more reminder that 3I Atlas refused to be simple. Unlike smooth or evenly weathered asteroids, this interstellar visitor looked rough in a totally different way. 3I Atlas showed sharp contrasts across its surface, almost jagged, like fractured plates or ridges shaped by forces scientists weren't used to seeing. If it had been stretched or squeezed by tidal forces during close encounters with planets and other star systems, those stresses could have left scars far more extreme than anything found on local space rocks. Unlocking those secrets depended on non-stop observation as the object raced closer. But time wasn't on anyone's side. Even though 3I Atlas was inbound, Earth-based telescopes struggled to track it consistently because it was faint and distant. Webb stayed the MVP, the only tool delivering clean, reliable data. But even Webb had limits. Its observation schedule was already packed, forcing scientists to fight for time against countless other missions. Still, the urgency of this moment couldn't be ignored. Schedules were reshuffled, priorities shifted, and Webb stayed locked on 3I Atlas as long as possible. Every new scan mattered. Tiny temperature shifts, surface changes, and motion quirks sparked intense debates. No detail was too small when dealing with something this strange. The discovery also reopened a much bigger question. How common are events like this across the galaxy? If the solar system has encountered multiple interstellar objects in just a few decades, maybe this isn't as rare as once believed. In dense regions of the Milky Way, overlapping gravitational fields could be flinging debris across star systems more often than anyone expected. That idea shook planetary science to the core. It suggested that planets across the galaxy might share more connected histories than we ever imagined. Their surfaces threaded together by a slow but constant exchange of wandering fragments. Attention then turned to the long game. Scientists weren't just thinking about the impact, they were thinking about what comes after. On Mars, erosion moves slowly, meaning the crater could stay preserved for millions of years. That site could become a geological time capsule. Future robotic missions, and eventually humans, could study it layer by layer. The ejecta would tell a story frozen in stone, blending Mars' own history with material forged around another star, a permanent record of a galactic encounter written right into the planet's surface. From the instant of impact to the slow settling of fine red dust, scientists started asking one big question. How deep would 3I Atlas actually punch into Mars? If the object was especially dense, it might blast through multiple rock layers before breaking apart. That kind of tunneling hit would send powerful shockwaves underground, cracking formations kilometers away from ground zero. Tracking those fractures could unlock hidden features beneath the surface. Mars is believed to be packed with underground lava tubes and ancient sediment channels, and a sudden surge of energy could expose or collapse parts of that hidden world. That chaos could turn into opportunity. Instead of drilling blindly, scientists might get a rare indirect look at Mars' underground terrain, revealed by raw force alone. Preparing for that flood of information, AI developers stepped in fast. New systems were trained to process incoming data the second it arrived. With satellites, telescopes, landers, and sensors all firing at once, humans alone couldn't keep up. Machine learning tools could flag subtle chemical traces, heat anomalies, or strange patterns emerging from the impact zone before anyone else noticed. That speed could trigger rapid follow-up observations while conditions were still changing. This moment marked a major shift in how humans study space. AI wasn't just assisting anymore, it was becoming essential to cosmic discovery. The interstellar roots of 3I Atlas also pushed scientists into deeper debates about how planetary systems live and die beyond our own. If this object was flung out during the violent birth of a distant star, its journey started long before Earth's continents even formed or Mars lost its oceans. The thought of such ancient material now racing toward a nearby planet hit hard. It put cosmic timescales into perspective and reminded everyone how connected these systems really are. Planetary systems separated by light years might still share history through wandering debris like this. Their stories overlap across time and space. Speculation didn't stop there. Researchers also wondered how many worlds 3I Atlas might have brushed past on its journey. Every close encounter with a star or planet could have bent its path just enough to send it toward Mars. That final trajectory wasn't random. It was the end result of countless gravitational nudges, a long cosmic chain reaction finally reaching its breaking point. Even though tracking every past encounter is almost impossible, the idea that 3I Atlas may have brushed past multiple star systems added serious mystery to this whole event. Every tiny deflection along its journey mattered. A slight gravitational nudge here or there could have decided not just when it arrived, but exactly where it would hit. That reality put a spotlight on how insanely sensitive celestial mechanics really are. Interstellar travel isn't random chaos. It's a precise, high-stakes dance where even small forces carry massive consequences. As Mars missions geared up for the collision, the conversation expanded fast. Planetary defense experts jumped in, not because Earth was in danger, but because this was a wake-up call. Interstellar objects don't play by the same rules as homegrown asteroids. They move faster, act stranger, and are way harder to predict. Watching 3. I-Atlas slam into Mars would give scientists a real-world test case, a chance to study impact physics involving an object born outside our solar system. That data could shape future defense strategies and technology in ways simulations alone never could. At the same time, excitement around human exploration of Mars surged again. This collision might rip open regions packed with scientific value, spots that could become prime targets for future crewed missions. If new formations or exotic materials show up, those locations could jump straight to the top of the landing site list. The thought of interstellar material just sitting on the Martian surface lit a fire under mission planners. New ideas started flying around, focused on sample retrieval and deep analysis. These missions could finally blur the line between planetary science and astrophysics in a way we've never seen before. Mars wouldn't just be a neighbor planet anymore, it would become a crossroads of galactic history. If you enjoyed this breakdown, smash that like button, subscribe to the StellarDrift channel, and share this video with anyone who's into space mysteries. Drop a comment below and tell us what you think would really happen if an interstellar object hits Mars. We want to hear your take. Thanks for watching, and we'll see you on the next one.